This video is part of Clos Fabric's Explained webinar with Brett Hedlund. To learn more about this webinar, visit ipspace.net.
Here we have a leaf and a spine in our Clos Fabric. So the leaf in this case would be the top rack switch. And as Ivan mentioned earlier, you're typically going to have a 3-to-1 oversubscription in that top of rack switch. And that is calculated based on 48 10-gig ports facing into the server cabinet for the servers. And then we have 160 gig of bandwidth as uplinks to our spine layer. That 160 gig of bandwidth could be provisioned in one of two ways. In the way that we're showing here, it is 4 links of 40 gig Ethernet to get 160 gig of uplink and my 3-to-1 oversubscription. So if I'm going to use 40 gig as the uplink to the spine, then I'm going to need a spine layer that has the 40 gig port density to achieve the scalability that I want to get out of this Clos Fabric. So with each leaf switch, each 4810 with 4 40 gig uplinks, that means I can have a maximum of 4 spine switches in this Clos. So one of the main design fundamentals of a leaf spine fabric or a Clos fabric is the number of uplinks that you have out of the leaf switch, in this case the top of rack, equals the number of spine switches that you can have at the spine layer. And with that number, which is 4 in this case, the amount that I can scale this fabric then depends on the port count of the spine switch. So in this case here with the Z9000, at 40 gig, there's a port count of 32 on each switch. So because of the spine switch having a port count of 32 40 gigs, that means I can have 32 leaf switches maximum. And 32 leaf switches times 48 ports per leaf switch is how we get to a 1,536 server port fabric at 3-to-1 oversubscription. Because the leaf switch is the top of rack switch, we're going to work with the assumption that we're going to need fiber to go from the leaf to the spine. The spine is probably going to be located several racks away, if not many rows away. So we're not going to be within a short enough distance to leverage copper cabling. There are choices with 40 gig where you can have basically a 40 gig copper cable with a QSFP soldered on both ends of that copper cable. That's called an active, or it's just what's called a DAC cable. It's actually a passive cable, sorry, which can only go about 5 or 10 meters. But that's not going to be the case here. We're going to need to use optics to go from the leaf to the spine. So we'll be using QSFP optics, and we'll have to be cognizant of what kind of distance we can get from the leaf to the spine. You'll have to understand what kind of fiber is in the infrastructure or that you plan to lay in the infrastructure. If you have relatively new fiber, which would be OM3 or OM4 fiber, OM4 fiber being the latest, and if you're using the newest QSFP SR optics, the newest one that is available from Dell, for example, is an enhanced SR optic where you can get a distance of 400 meters from the leaf switch to the spine switch.
To get more information about my webinars, to register for an online session, or buy a recording or the yearly subscription, please visit my website.